வாகை சூடவா.
Hi NEET aspirants, here I am to deal with the topic electromagnetic induction. It's a very important and interesting topic from which you get a minimum of 3 questions in your NEET exam. This is your 4th lesson in your 12th standard syllabus and I hope you have learnt it thoroughly. Yes? Right. Now, to start with the topic, because let me take a brief period of time to deal with the concepts as we have learnt it already and then move on to the problems and how to deal with the problems. I think that is more important for you now at this stage as you are waiting to face your NEET exam, right. There are only 5 or 6 concepts that you should learn thoroughly, that is more than enough, and mere substitution of values in the formulae is enough for this chapter. It won't be very mind-blogging or very difficult or very tough. Be thorough with the concepts, be thorough with the formulae. That is more than enough for this topic and I hope you will be able to crack your NEET questions with all the concepts that I do now in this session. I hope I have covered all the vital concepts that are required for you to do so, right. Getting into the topic seriously. To start with, Oersted was the scientist who proved that if you have a conductor, there is a magnetic field around the conductor. Later on, Ampere proved that if there is a coil carrying current, right, one side becomes a north pole, the other side becomes a south pole and it behaves like a magnet. So, what is happening here? If there is a current, there is a magnetic field. Since nature loves symmetry, Faraday was thinking about it. If we can get magnetic field from current, then is the converse possible? That is, can we have this electric current from magnetic field? So, what did I say? I will just repeat. If you have current, you get magnetic field. Faraday thought of the converse process, that is, from the magnetic field will we be able to get the current. That is why we have all these AC generators, DC generators, because only based on the Faraday's idea now we have the generating AC circuits, right. So, now moving, so electromagnetic induction is basically based on Faraday's experiment, okay, for that. So, how to get current from magnetic field? Magnetic flux has to change. So, what is magnetic flux? Flux is nothing but the number of normal lines of force passing through the given area. If you have an area, we call this as an area vector, right, perpendicular to the surface. And if lines of force, magnetic lines of force are passing normally to the surface, the number of magnetic lines of force passing through the surface is called as magnetic flux linked with the surface. Now, we have got the basic idea of flux. How do you represent mathematically? Flux is a scalar quantity. So, it is a dot product of magnetic field and area vector. Okay. So, integral as it is given in the monitor, integral B dot dA. B dot dA is B dA cos theta. If you integrate it, you get BA cos theta. So, remember, this is the basic, the first step that you ought to remember. All that you do will be starting only from this. Any problem given in this chapter has to be started only from this basic thing, that is, what is magnetic flux? BA cos theta. Remember that, okay, right. So, how to get current from the magnetic field? Magnetic field, that is, magnetic flux has to change. The change in magnetic flux can induce EMF, that is voltage, from which you can get current. That is why the name suggests electromagnetic induction. Magnetic flux change will induce EMF. So, the very name suggests that. Now, Faraday did many experiments and gave us Faraday's laws. According from the Faraday's first law, we have induced EMF if there is change in flux. And what is the amount of induced EMF? It depends on the rate of change of magnetic flux. So, that is the key and vital aspect of the chapter from which you will be doing all the problems in this, right. So, that is the first topic, the phenomenon of electromagnetic induction. You can do umpty problems from this, right. And then Lenz law. Now, you know you have current, induced current produced by the changing flux. Now, how to find the direction of current that was given by Lenz law? It is nothing but about you. What do? You oppose your parents, you oppose your well-wishers. The same way the Lenz law states that the induced current always opposes its own cause, that is the change in flux. So, this is a beautiful concept which makes you think vividly to find the direction of current. You should always keenly note what is the actual change that is happening. Then how should the current be so that cause can be opposed. So, it is always a diagram based question. We are going to deal some of those questions in the last part. Okay? Actually, I am going to do this around 30 problems. Then the other thing is, if you have a coil, then the coil is carrying current, then flux is linked with it. You have magnetic field and therefore flux. When the current changes, field changes, flux changes. Again, EMF is induced on itself, right. This is self-induction. So, due to the self-inductance property of the coil or self-inductance property of a solenoid. What is a solenoid? A wire wound around like this with some distance between the turn. So, in a coil, inductive property of a coil or inductive property of a solenoid induces EMF on itself. What about one influencing the other? One coil can induce EMF in the other coil, which we call as mutual induction. Based on that also, we are going to do problems. And then finally, various methods of inducing EMF. Now, let us move on to look into the formulae list. Quickly go through it so that we will have enough time to deal in detail with the problems. Flux, just now I told you, do not be scared about the number. Actually, initially one or two are very important. If you are thorough with those, all the remaining formulae are just derived from it. So, I will quickly tell you how the formulae are derived from the first few, right. So, flux is B dot dA, the first one here, right. Then the next one is induced EMF. According to second law, according to Faraday's first law, it depends on the rate of change of magnetic flux, right, d phi b by dt. This is xi. This represents induced EMF. So, this is because of rate of change of magnetic flux. Once you have EMF, it is easy for you to find current. It is voltage by resistance according to Ohm's law. So, xi by R, that is the next one. This is one, right. The fourth one is charge. How to find the charge? Again, go back to the first. What is xi? d phi b by dt. What do you want? Charge. What is charge? I is equal to dq by dt. So, dq is equal to I dt. What is I? I is xi by R. So, substitute for it. Finally, you land up with the formula Q is equal to del phi B by R. This is one of the very important formula which is very much required to solve your NEET problem, and it is very often tested concept. Please remember, charge induced is nothing but the change in flux divided by resistance. Now, this is motional EMF. See, if you have a coil, rectangular coil, right, and in which the conductor placed on it is moved, then EMF is induced in the conductor. This is one way, right. So, what is the EMF induced in the conductor? It is derived as BLV, have learnt it in your 12th standard. Okay. Once you know EMF, now remember this is translatory motion. Translatory motion of the rod on a rail like circuit will induce EMF in it, which is xi is equal to BLV. Okay. Once you know EMF, it is easy for you to find the current and then the force. What is force? It is BIL, B-I-L. Actually, to represent it vectorial, it is I into L cross B. You have done it in your third chapter. Okay. So, BIL, okay, B into I. What is I here? BLV by R into L. If you multiply, you get B square L square V by R. Then power. Power is nothing but voltage into current. So, here you have BLV and here you have BLV by R, multiply them, then you get B square L square V square by R. So, these are not very difficult ones once you know these 2 or 3. One is Xi is equal to d phi by dt, the other one is current is equal to voltage by resistance, that you know already, and then finally the heat dissipated is what? It is B square by R into T. You have learnt 3 formulae for heat dissipated based on Joule's law, I square RT, V square by R into T, and then VIT. We are using V square by R into T, that is voltage, then it is V square by R into T, right. Then some more formulae for you. Now, what happens if a conductor in a magnetic field rotates? It is not translatory motion, it is rotatory motion. In that case, what is the EMF induced? We are going to deal this as one of the problems in our list, because this is also given as an worked out example in your textbook. This is again a very important concept tested again and again in your NEET exam, right. It is B, remember this, B L square omega by, right. Then heat dissipated is again the same way you can find out. Self-inductance, coming to the self-inductance. Now, if a coil carries current I, phi is the flux linked with it, then phi is proportional to I, phi is equal to Li, then L is equal to phi by I. This is self-induction. So, phi is equal to Li. If the flux changes, it is d phi by dt, that is Xi, then L di by dt. So, L is equal to phi b by I, then Xi is equal to L di by dt. Then you can derive the formula for self-induction. L is equal to mu naught n square A L. What is that small n? The small n denotes here, the small n denotes the number of turns per unit length. If you want to express it in terms of the total number of turns, then it becomes mu naught n square A by L. And if a medium is also introduced into that coil or a solenoid, then the formula becomes mu naught mu r n square A by L. Though this is the formula by definition, that is induced EMF is change in flux d phi by dt, d by dt of Li, L di by dt. Then based on, actually the inductance does not depend on current. It depends only on the physical dimensions of the solenoid. So, it clearly shows that it depends on the medium, depends on the number of turns, area of cross section and the length. If a medium is also introduced, it becomes mu naught mu r n square A by L, where mu r is the relative permeability. Then some more. Then here we have mutual induction. Whatever you have done for self-induction, you can do it for mutual induction also, right. How you wrote phi is equal to Li, here change in the current through one coil induces EMF in the neighboring coil, right, like how you cry for your friend, right. So, if the current changes to the first coil, EMF is induced in the second coil, and this EMF induced Xi is equal to m di by dt. How you wrote Xi is equal to L di by dt, it is all similar. Phi is equal to Li, phi is equal to mi. Xi is equal to L di by dt, then Xi is equal to m di by dt. Okay. There you have mu naught n square A L, here mu naught n naught ni A L. What is n naught? Number of turns in the outer solenoid, ni is the number of turns in the inner solenoid. You have 2 solenoids here. If one more medium is introduced, then it becomes mu r mu naught n naught ni A L. Here these 2 represent number of turns per unit length. If both self-induction and mutual induction are to be considered, you have to add them and get the induced EMF. And finally, right, AC generator, I told you the change in flux will induce a current. This is the basic principle of AC generator. The EMF induced in this due to change in theta is xi m sin omega t. Now, induced EMF Xi is equal to d phi by dt, d by dt of phi, d by dt of B A cos theta. So, when will you have induced EMF? When B changes, A changes, theta changes with respect to time. Many of the problems are based on this formula only. So, you have to identify which is changing, whether B changing or area changing or theta changing. Now, coming to the first problem, what is given here? Rectangular coil of 20 turns. So, N is given, area of cross section is given. So, N R. So, whenever you read the problem, read it carefully and note down symbolically, right, how do you represent these physical quantity? Number of turns N, then area of cross section A, then resistance 100 ohm. Of course, in many of the problems, the magnetic field will be perpendicular to the coil. Always when you take the coil, the magnetic field will be perpendicular to the coil, which means B vector and A vector are along the same direction. Since B and A are along the same direction, the angle between them will be 0 and cos 0 is equal to 1. So, in the formula, B A cos theta, in many of the problems it will happen to be cos 0, which is 1. So, which are the two things to be considered then? B and A. Either B will be changing or A will be changing. Here changes at the rate of 1000 Tesla per second. Tesla is a unit of magnetic induction. So, which is changing here? B. Okay. Now, see what you want is current. So, any problem, first step flux, second step induced EMF, third step current. That is all. Whatever you want, you can just proceed with it. So, first step induced EMF. What is induced EMF? It is d by dt of N B A cos theta. Cos theta has become 1. So, N A dB by dt, right. If you want current, Xi by R, that is N A dB by dt by R. And you can revise it later on to cover all the concepts. I is equal to Xi by R, Na dB by dt by R, that is substituting all the values here, 20, converting area centimeter square into meter square, 10 power minus 4 into number of turns by resistance, you get the value 0.5. So, the subdivision C is the answer. Shall we move on quickly so that we can cover the 30 problems fast? Right. Then the second question, I told you even in the beginning, right, when the rod slides, that is it has translatory motion, then the induced EMF is BLV. If the rod is rotating, then the induced EMF is half B omega L square. I told you that we will be doing the proof. See, here only from that we are doing this. What happens here? This part of the rod, small portion of the rod is moving with a velocity v. Then it has translatory motion in this direction for a small distance. Then in that case, you can use the formula BLV. Where is this small portion? This small portion is at a distance x. Now, why do we do like this for a small element? Because with the distance x, the velocity v will also be varying. You have learnt in your 11th standard v is equal to r omega, and whenever there is a rotational motion, right, omega will be same, right, as r changes, v changes. V is equal to r omega, omega is constant, as r increases, v also increases. That is why you consider a small tiny element here of the rod dx, right, which is moving with a velocity v. Then for this portion, use that translatory motion formula here. Then dz is equal to BLV, B dx v. Fine. Now, what is v? V is equal to r omega. Where is this now? With a radius of x. So, in the place of v, you substitute r omega, that is x omega. The matter is simplified. So easy it is. So, from that we have found out the EMF across the small element. Then for the entire rod, what will it be? Integrated. Then integral b omega x dx. B omega is taken out, integral x dx, varying the limit from 0 to L, where L is the length of the rod. Integral x dx becomes x square by 2, that is L square by 2. Hence the formula half b omega L square. Immediately try to retain this. Fix it in your memory. This is a very important formula. You ought to know before you write your NEET exam. Many of the NEET exams had this concept in it, some way or the other. So, whenever a rod rotates in a magnetic field, what is the induced EMF? Come on, I can hear you saying half b omega L square. Thank you. Then question 3. Here, this is your lovely friend. What is it? Wheatstone bridge. See, P by Q is equal to R by S. your eyes did not go to the circuit. Your eyes automatically had gone to the portion that you like the most. Don't you like Wheatstone bridge solving? Yes. So, P by Q is equal to R by S. So, this is a balanced state of Wheatstone bridge. So, this is as good as absent. This 3 ohm is as good as absent, right? Then here have to solve. What is asked? It's a square metal loop, okay? Then of side 10 centimeter. So, this portion is of the length 10 centimeter, that is 0.1 meter. Resistance is given, its velocity V, right? In magnetic field is given. Fine, and again magnetic fields, if it is given as cross, it is into the paper. If it is given as dot, it is coming out of the paper. The loop is connected to the network here, that is second chapter is attached to the fourth chapter here. The problems will be only like that, each of resistance 3 ohm. So, simple way of solving this. See, this 3 ohm and these 3 ohm are connected in series. So, 3 plus 3, 6, and this 3 plus 3 is again 6. Right. Now, solving these two, 1 by 6 plus 1 by 6 you get 1 by 3, and therefore, equivalent resistance of this network becomes 3 ohm. So, what is the external resistance? 3 ohm. So, you have the external resistance to be 3 ohm. Fine. Now, what is it? First step, flux. Next step, induced EMF. So, what is done here? Induced EMF is for a rod moving having translatory motion? Yeah, it is BLV. So, here you used a formula, Xi is equal to BLV, and from that you can find current I is equal to Xi by R, that is BLV by R, from which you write V is equal to IR by BL. All the terms are available in the formula except for R. R is calculated for as 3 ohm. Then you have substituted here. Then you find the answer to be 2 into 10 power minus 2 meter per second. Going on to the next. This is a very easy problem. See, flux is directly given as a function of time. Here you need not find out whether is that B or theta or A which is varying. Directly it is given as a function of time. If you are strong in maths, this is going to be nothing for you, right? What is induced EMF? d phi by dt, d by dt of this. Such problems are given in your textbook also. Differentiated 20t. Then here it is minus 50, of course, there is a minus sign. We have seen Lenz law, it always opposes the cos, hence the negative sign. So, you must take it into consideration here, minus 20t minus 50. When is it asked for? T is equal to 3 seconds. Substitute for t as 3, then you get this answer minus 10 volt, and hence the answer is subdivision B, which is 10 volt. Question number 5. Yeah. You have to slightly think. All these problems so far were very easy for you. This may be somewhat difficult. Not so once you see what it is. A metal rod of resistance 20 ohm is fixed along the diameter. This is the question. Actually, this diagram is for the question. It will be given along with the question. This is the part you have to solve for, right? So, this is what fixed along the diameter of resistance 20 ohm. So, share it 10 ohm and 10 ohm, right. Then the radius is 0.1 meter. Then you get the length of this portion, right. There is a magnetic field. The ring rotates, which means this is also rotating. What is the formula for rotating? Half B omega L square, isn't it? Yeah, so see half B omega L square. Instead of L square, you take R square here. This is rotating. So, calculate the induced EMF between A and O, which will be same as the EMF between O and B. So, what is the EMF then? Half B, value of B is 50 given in the problem. Then omega, which is also given in the problem as 20 radian per second, and then R is the radius, which is 10 centimeter, 0.1 meter. Fine. So, calculate it as 5 volt. So, between A and O you have 5 volt and also a resistance of 10 ohm. So, I have to draw now 5 volt and a 10 ohm. Again another 5 volt and a 10 ohm. Here there is an external resistance 10 ohm, which is also given in the problem. An external resistance of 10 ohm is connected across the center of the ring and the rim. Center and the rim. Between these two, this point and this point, an external resistance 10 ohm is connected. Right. Now, is the battery 5 volt with a resistance 10 ohm. 5 volt connected to a 10 ohm. Now these two are connected in parallel. So the net potential difference will be 5 volt and these two resistors are connected in parallel. What is it? 1 by R, 1 plus 1 by R2, that is 1 by 10 plus 1 by 10, 2 by 10, which is 1 by 5. Therefore equivalent resistance becomes 5 and the external resistance is 10. So the total resistance becomes 15. So it is by solving 5 by 15, 10 plus 5, that is 15, which is 1 by 3 amp. Next question. N is given, A is given, then as usual it is perpendicular, so cos 0 is 1, B is given. This again I saw this in many of the NEET exams. This concept is also, what is happening here, theta is changed, B, A, cos theta. So far we have been taking cos theta as 1, cos 0. Now in this case that cos theta is changed, B is fixed. If number of turn is n, then you have to take it as NBA cos theta. Right? Now NBA cos 0 initially, NBA, then NBA cos 180 as it is rotated through 180 degree, then NBA cos 180, which is cos 180 is minus 1 minus NBA, then what is the change in flux? Phi 2 minus phi 1 minus NBA minus NBA minus 2 NBA. What is the magnitude of change in flux? Which is 2 NBA. Therefore, the average EMF induced will be rate of change of magnetic flux, which is 2 NBA by delta T. Delta T is given as 0.2. Substituting for it, you get it as 10 millivolt. Then the next question. This is somewhat interesting one. The flux is given. Once flux is known, you know the induced EMF, right? Then it's going to be easy for you. What is asked? Amount of heat generated, flux, induced EMF. Once you know EMF, what is the power? Energy generated, V square by R into T. Then integrate it and calculate, right? That is what is done. EMF d phi by dt minus d by dt of, what is flux here? A t tau minus t. Here tau is a fixed value, t is a variable. It is, we are calculating it from 0 to tau. Then minus d by dt of a t tau minus a t square. By differentiating you get this. Absorbing minus sign, it becomes 2at minus a tau. The amount of heat generated will be dq. For a small time interval dt, it is going to be what? V square by R into dt, that is xi square by R into dt. Then finally the total heat generated Q will be integrated between the limits 0 to tau. Now you have to expand this. A minus B the whole square, A square plus B square minus 2AB. Then dt. Here tau is a constant, 4a square, t square is integrated as t cube by 3. This is integrated, a square, t square is a constant, dt is integrated as t, and substituting the limits. The final thing is 4a square tau is a constant, t is integrated as t square by 2. Substituting for the limits and grouping all these terms, you get 1 by 3 a square tau cube by 3. A little of mathematical skill is needed for this, but the physics part of it is so simple. Just finding out d phi by dt for a small time interval t. Question number 8. This is very cute problem. What is it? A conducting ring of radius r is placed in a, usually so far we have been considering either the coil is moving or the conductor is moving. Now in this case the ring is at rest and there is a magnetic field and the magnetic field is changing. Okay, we saw one problem like that, changing magnetic field. Here the ring is at rest and the magnetic field is changing, and the varying magnetic field at the rate of change of magnetic field, right? What is it? dB by dt. You just substitute for dB by dt as x. What is asked for? EMF is induced in the ring. What is the EMF induced in this? That is electric field intensity E vector is asked for. EMF is potential. Now what do you go for? What is potential difference? Potential work done, force dot displacement. Integral E dot dl. Line integral of electric field is potential difference, that is induced EMF here. Now if we consider this ring, right, electric field will be along the ring and this dl is also along the circumference of the ring. At any point E vector and dl vector will be along the same direction, that is E vector and dl vector are always parallel. Then E dot dl becomes E dl cos 0, E dl integrate E into, what is integral of dl? Integral of dl is the circumference of this ring. What is circumference of ring? 2 pi r. So E into 2 pi r, that is you find out xi by finding out this line integral. So, one way of finding out xi is, what is it? E into 2 pi r. What is the other way? The usual formula, d phi by dt. What is d phi by dt? It is d by dt of Ba cos 0 here, right? Ba, which is changing. A is pi r square, it is a ring of area pi r square, right? Then dB by dt. What can you substitute dB by dt? It is given in the problem that dB by dt is nothing but x. So, substitute for this x as x. So, this is pi r square x. So, you have xi as pi r square x based on the definition, and here you have calculated for EMF as E into 2 pi r, equate this and this, you get E is equal to Rx by 2. Ninth problem. Here you have L, I, B, right? Noted down our thing. Then what is it you want? Power. Electric power is voltage into current. How to find the voltage? It is nothing but induced EMF. What is induced EMF? See what is happening here. A conductor carrying current is held perpendicular to a magnetic field. Power required to move the conductor. So, if you have to move the conductor, what is the induced EMF? That is the voltage, BLV. So, for voltage into current, it is BLV into I. Just simple substitution. You need not worry at all. Just find the answer, substitute, and it's all very easy calculations with powers, 10 powers, right? Then next one is question number 10. You have copper wire of length 50 centimeter. L is given. Resistance is given, is formed. Now, there is a small trick here. The length of the wire is 50. It is formed into a circular loop. So, what is it you have to find out? The radius. That is the first step then, right? 50 centimeter is the length of the wire. Now, 2 pi r is equal to 50, then r will be, you have to calculate for it. It is 1.1 into 10 power minus 2. So, what will you do with the length here? Don't be thinking about it. Once you made it as a circular loop, calculate for radius, fine. And similar to the previous problem, here the magnetic field is increasing at a constant rate. Previous problem it was given as x, here the numerical value is given as 10 millitesla per second. What is milli? 10 power minus 3, I hope you know students. Milli is 10 power minus 3, micro is 10 power minus 6 and nano is 10 power minus 9. All these should be, you should give and get it in your sleep. Should be like that, right? At what rate is thermal energy generated in the loop? Again, voltage, current. Once you know these two, once you know voltage, that itself is enough for you to calculate the power. Once you know voltage, what is power? V square by R, xi square by R. So, to get the voltage, go back. What is xi? D phi by dt. That is d by dt of BA. A is area pi r square dB by dt. dB by dt is directly given in the problem, 10 millitesla. Pi r square you have calculated for r. So, you pi, this is V, voltage. So, what do you want? V square by r into t. So, calculate the entire thing, you get 3.63 into 10 power minus 6 watt. The calculation would be very tough for you in this. Then question number 11. Here, there is a simple theory proof. It's somewhat like that. A conductor moving here, right? Here I have to explain, I want to explain one important thing here. When the rod moves to the right, fine, then the electrons inside the rod is the metal rod. So, it must have electrons in it. So, the metal rod inside, the electrons inside the metal rod must also be moving towards the right. The electron, charged particle is moving in a magnetic field, must experience a Lorentz force. Right? How? If you keep your finger and find out, finally you will find out that the force experienced by the electron will be downward. So, electrons get accumulated at the lower end, making it negative, and the upper end becomes positive, right? There will be an induced EMF. This is what we named as motional EMF, right? Once you get this, that is what I have given here. EMF induced in the rod causes a current to flow in the this is plus, this is minus. So, how will the current flow? From plus to minus, like this, in the anti-clockwise direction. Because of this current, now there is a current like this, see, anti-clockwise. So, here it flows from this end to this end. So, this is the direction of current. You have conductor carrying current I placed in a magnetic field must experience a force to the left. So, again this is, see, the induced current is opposing the cause. Because of the induced current is experience a force inward. The rod is trying to move outward. So, you have to apply a force to the right to sustain the cause. Pull the rod to the right at a constant speed, right? This force must be balanced by the puller. Then the EMF induced in the rod is Xi is equal to BLV. Find the EMF induced, that is the voltage, right? And then hence you can find the current. What is it? Xi by R, voltage by resistance. Ohm is your friend, right? 0.05 amp. Now again force, we saw it in the beginning. Even in the list of formulae we saw that, Bill, ILB. So substitute for that, ILB, they are going to be perpendicular, L and B. B is into the paper. B cross means into the paper, right? L and B are perpendicular. So ILB sin 90. So ILB into 1, you get the answer. Just two formulae to be remembered. Xi is equal to BLV because it's a rod moving having translatory motion from which you find current, and hence you can calculate the force, which is BIL. Then question number 12. Two identical coaxial coils P and Q are moving towards each other. They are carrying current in the same direction. You have one coil and you have the other coil. See, you have current in this also, you have current in this also. If this is the direction of current, this is the direction of magnetic field in this case also. Both of them having the same type of flux. So if they move towards each other, this will increase its flux, this will increase its flux. And what will this Lenz law do? It will oppose the cause. It will not allow the flux to increase. So it will induce a current in the opposite direction in this as well as in this. So the induced current will be opposite to the direction of the current that is flowing. So what will happen to the current in both? In both the current must be reducing, right? So here obviously a subdivision is both P and Q, the current will decrease. That is the problem. Two identical coaxial coils PQ carrying equal amount of current in the same direction are brought nearer. The current in both P and Q decreases. Fine. Then this is a very trivial question. Current changes from 2 ampere to 4 ampere. So I1 is given, I2 is given, time is given. Then EMF voltage is also given. What does he want? Just very simple, self-induction. The beginning I told you phi is equal to Li. d phi by dt is equal to L di by dt. So what is L? Induced EMF by E by di by dt. E by di by dt. dt comes up. So E into Xi into, that is Xi dt by di. So Xi is equal to L di by dt, from which you get this. Such problems are very easy for you. I hope you get such problems, easy problems for you in this coming NEET exam, right? Then the next one, question number 14, right? Now we are moving on to the solenoid, right? Area of cross section, you have to remember the solenoid now. What is the magnetic field inside the solenoid? You remember mu naught small n into I. What is small n? Number of turns per unit length, okay? Then cross sectional area A, area is given, the length is given, number of turn is given. What is it? Straight substitution formula. You have derived this for in your theory classes. Mu naught n square A by L. What does capital N stand for? It stands for the total number of turns. Well, how many turns are there? 1000. Just substitute. Mu naught, of course you know the value. Permeability in free space 4 pi into 10 power minus 7 into 1000 square into area is converted to meter square. Centimeter square is written as 10 power minus 4 divided by, here you have L. What is L here? L is given as 0.1. So mere substitution is again a very easy problem. Question number 15. By changing the current from 5 amp to 10 amp in 0.1 second, the self-induced EMF change. See, it looks similar, but the question goes for something else. It is not inductance, it is the energy. Actually, in the list of formulae, I think I have to mention this formula, you have to remember. And it's very simple, like 11th standard. What did you learn for kinetic energy? Half mv square. The first chapter, half cv square. Energy stored by capacitor. So for inductor, half Li square. Everything is just similar to remember for you easily. Half mv square, half cv square, half Li square. Here half Li square. Calculate the initial energy. U1 half Li1 square, half Li2 square, half Li2 square minus half Li1 square. That's all. So simple. 16. The energy stored in a magnetic field is again asked for. The same formula to be used, but you have to calculate for L in this. I is given, flux is given. The very first formula, phi is equal to Li. See, if there are n turns, then it is n phi is equal to Li. Fine. If there are n turns, you should take it as n phi is equal to Li, from which you get L, and then direct calculation half L I square. Right. Two conducting circular loops of radii R1 and R2 are placed in the same plane with the centers coinciding. There are two circular loops. One is a big one, the other one is a small one. What is asked for? Mutual inductance between them will be directly proportional to. Right. So, what are we doing for? What are we trying to do now? You have one big circular loop and a small circular loop. Right. A big circular loop and you have a small circular loop here. What will be the magnetic field at the center of circular loop? Now, remember the third chapter. If you have a straight conductor, what is the magnetic field at a point? Mu naught I by 2 pi r, right? If it is infinitely long. If the length is restricted, it is mu naught I by 4 pi a into sin phi 1 plus sin phi 2. If it is a circular coil, what is the magnetic field at the center? Along the axis, mu naught n I a square by 2 into a square plus x square the whole power 3 by 2. If it is at the center, then it is mu naught I by 2a, right? You are using just that. So, for a circular coil, concluded all the formula for you from the third lesson, right? What is this circular coil? Magnetic field at the center, it is mu naught I by 2a, where a is the radius of the circular coil. Here the radius to be taken as r1. So, what is the magnetic field? Due to the big circular coil, what is the magnetic field at the center? It is I1 is the current here, then the magnetic field at the center will be mu naught I1 by 2 pi R1, fine. That is what is given here, right? Mu naught I1 by 2 R1. So, you have got B1. What is flux? B1 into A. B1 is mu naught I1 by 2 R1 and area is pi R2 square. So, this flux linked with the second, that is the smaller one, depends on what? R2 square and R1. All these are known things, right? Now, you get flux linked with the smaller coil by using the basic formula for magnetic field at the center of circular coil and the definition of flux, phi is equal to Ba. And you also define for it as phi is equal to Mi. Phi is equal to Ba for by definition for flux, phi is equal to Mi based on mutual inductive property, right? Phi is equal to Ba, phi is equal to Mi. For phi is equal to Ba, you have calculated B1 into pi R2 square. Phi is equal to Mi, M is equal to phi 2 by I1. Simply have this here, you get that I1 cancelled. Then what do you get here? R2 square by R1. So, 17D R2 square by R1 will be your choice of answer. Be careful while looking at the answer. So, there will be what similar to confuse you. Just carefully, you be very confident with your answer and then look for the options, right? A small square loop of wire, side L. See, there is a square loop of side L, right? The side of the square loop is L. This is length small l and the bigger one is capital L, fine. Now, what is asked for? The loops are coplanar, that is they have a common center and the centers coincide given. What is the mutual inductance of the system? How do you find the mutual inductance? Again, two things, phi is equal to Mi, right? Based on the formula you find out. I told you now, if you have a conductor of restricted length, what is the magnetic field at a point? Mu naught I by 2 pi a if it is of infinite length. If it is of restricted length, mu naught I by 4 pi a into sin phi 1 plus sin phi 2. Remember? Right, now here mu naught I by 4 pi distance. What is the distance of this side from the center? That is, you want the magnetic field here. You want the magnetic field here. Because of this current, if you apply the condition, right? So, due to this portion, again the current is magnetic lines of force. Again, how is it going to be? Due to this portion, like this. So, be it this or, how do you get the magnetic lines of force? Always pointing towards me. So, all the four sides, this side, all the four sides contribute to a magnetic field at the center in the same direction, so that you can add them up, fine. So, what is the magnetic field at the center? So, where is the center now? The length is L. So what is the middle portion? It is L by 2. So from this portion of the conductor, from this part of the wire loop, this conductor, what is the length then? It is L by capital L by 2. So mu naught I by 4 pi, mu naught I by 4 pi L by 2, right? Then as it is a square, it should be 45 degree and 45 degree. So sin phi 1 plus sin phi 2, sin 45 plus sin 45. What is sin 45? 1 by root 2, 2 by root 2, right? It is, how many sides you have? 4 such sides. So multiply by 4, 4 into this. Sin 45 plus sin 45, this 4 gets cancelled, simplify this, you get 2 root 2 mu naught I by pi L. A simple calculation is involved in this, not much. So you get B here as this. What do you want flux? What is it? BA. So you have B here. What is it you have to do then? A2. What is asked for? Mutual inductance of the system. Calculate the flux. Phi 2 linked with the smaller loop. Use the definition. Phi 2 is equal to Mi1. Right? So you have one phi 2 here based on this calculation. Another phi 2 based on the definition of mutual induction. M is equal to phi 2 by I. Right? This phi 2 should be substituted here by I. I gets cancelled. Then you get M to be 2 root 2 mu naught I square by pi L. I hope you have understood. What did you do? You calculate for B due to a straight conductor. Multiply that by 4. You get B at the center. Once you know B at the center, this is the magnetic field in the inside the smaller loop. So what is the flux inside the smaller loop? It is phi 2, right? So phi 2 is equal to BA2. Once you have got flux inside this smaller loop, by definition, what is phi 2? Mi1. Right? So what is M then? Phi 2 by I1. Substitute for phi 2 by I1, you get the formula for mutual inductance between these two square loops. Then question number 19. Equivalent conductance of inductors 2.4 Henry when connected in parallel and 10 Henry when connected in series. See, here L1 and L2 are not given. If L1 and L2 are connected in series, you get 2.4. They are connected in parallel, you get 10. Equivalent value is given. You have solved such problems already, actually with the resistors. In the second chapter, current electricity chapter, similar problem has been done in your second chapter in your 12th standard portion. Right here, now one more thing I would like to suggest here is, think this way, okay? Ohm's law, V is equal to IR. V is the voltage. R is the value of the component. Okay, right? How is it related? Voltage is directly related to R. Coming to capacitor. Q is equal to CV. Fine. V is the voltage. How is it related to the component? Value of the component C. CV. So V is Q by C, inversely related to C. Here V is directly related to R, here V is inversely related to C. Now coming to inductor, E is equal to L di by dt. Here you have voltage, that is why I take this formula. E is voltage, L di by dt. So E is equal to L. One important point to note, V is equal to IR. How is V related to R? Directly proportional to R. Q is equal to CV. How is V related to C? The value of the component inversely related to C. V is equal to Q by C. Then coming to the mutual induction. E is equal to L di by dt. Fine. E is the voltage is equal to L. So how is voltage related to L? Directly related to L. Similar to the Ohm's law. So V is directly proportional to R. Here voltage is directly proportional to L. So how the way you deal with the resistance, the way you deal with the inductor. Right? Why did I say this? Because resistors connected in series, what is the formula that you use? R1 plus R2 plus R3. Similarly, inductors connected in series, use the formula L1 plus L2 plus L3. Whereas in the case of capacitor, what do you have? Q is equal to CV. V and C are multiplied. So V is inversely related to C. In that case, connected in series, it is 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. I hope you have understood what I am trying to convey. Right? Now here this is a very simple easy problem. Here L1 plus L2 is given, connected in series. Then parallel, connected in parallel, L1 L2 by L1 plus L2 is also given. You have to solve, find out L1 plus L1 L2 from this, 2.4 into L1 plus L2, 2.4 into what is L1 plus L2 into 10. So you have L1 L2. You are strong in your maths, fine. Then what is A minus B the whole square? Is A plus B the whole square minus 4AB. Substituting for all the values you get L1 minus L2. You have L1 plus L2 and you have L1 minus L2. Solve with these two equations to calculate for this L1 and L2, which are 6 Henry and 4 Henry. 20th question. Here you have frequency is given, peak value is given, right? Here is an oscillating current. Actually this is an overlapping of EM and AC. So I need to necessarily have to touch this because mutual inductance is involved, right? Which is M is also given. What is asked for? Peak value of voltage induced in the second coil, right? Now it is an alternating current. So I1 is equal to I0 sin omega t. Fine. So how do you find the flux? Phi 2 is equal to Mi1, right? M, what is I? Current, I0 sin omega t. This is I0. So M, I0 sin omega t d by dt of. So differentiate it. Sin omega t becomes cos omega t into omega. So which is the peak value? M I0 omega. Only this is asked for, peak value of voltage induced. So what you want here is M I0 omega. M is given, right? Peak value of voltage is M is given, I0 is given, omega is also given. Omega you have to calculate. Omega is 2 pi f, right? Since f is given, nu is given, you calculate for omega, 2 pi nu, 2 pi into 50. Right, and this is 150 into 10 power minus 3 and this is 2 current. So you I0 is the peak current. Calculate as 30 pi volt. The next question. Now here equal number of turns, N1 is equal to N2. Length and radii in the same ratio 1:2. What does it mean? L1 by L2 is 1 by 2, R1 by R2 is also 1 by 2. And what is asked for? Ratio of the self-inductance. You know the formula for self-inductance. Which are the three terms involved in this? N square A by L. So it is directly related. N1 square by N2 square, R1 square by R2 square. This is inverse related. Therefore it is L2 by L1. Since this is 1, N1 is equal to N2. R1 by R2 is 1:2. And L1 by L2 is 1:2. Here you want L2 by L1. So it is into 2. 1 by 2 the whole square into 2 by 1. You get it as half. This is very simple for you again. Question number 22. See, there are 4 inductors. It's like solving resistances in second chapter. They are the similar way have to be solved, right? This is NA, NA and NA. So 1, 2, 3, 4. All 4 are connected to NA. And similarly, all 4 are connected to NB. This is NB and this is also NB. Only this is somewhat similar. See, this end is connected to A and this is connected to B. Similarly, for all 3 you can see the 2 ends are connected between A and B, which means they are having parallel connection. How do you do for resistor? The same way here, 1 by L1 plus 1 by L2 plus 1 by L3 plus 1 by L4, solve and get it as 1 Henry. Then question number 23, a conducting circular loop is placed in uniform magnetic field, this plane perpendicular to the loop. R is shrinking, so dr by dt is given, starting from the beginning. Flux, BA cos theta, again cos 0, 1, BA, B pi r square, you have phi, what do you want? E, xi, d phi by dt. D by dt of B pi r square, that is differentiate pi r square since r is a variable, 2 pi r dr by dt, right? Dr by dt is given as 1 millimeter per second, right? R is also given. What is the value of R to be taken? When it is 2 centimeter, when the radius is 2 centimeter, is asking you for EMF. So here B is given 0.025, pi 2, R is 2 centimeter, dr by dt is given as 1 millimeter per second. Substitute and find the value as pi microvolt. 24. It's a capacity C, charge to a potential difference V1. Immediately it should come to your mind, Q1 is equal to C1, CV1. Q is equal to CV, right? Then plates of the conductor are then connected to an ideal inductor. It's a combination, it's a LC circuit. If it's an LC circuit, then it becomes an oscillator. If it's an oscillator, then you have the what? Omega is equal to 1 by root L. So you can use this, isn't it? Right. Then if Q, it is varying, it is getting discharged or charged. How do you represent the variation of charge with respect to time? Q is equal to Q naught cos omega t. Then cos omega t will be Q by Q naught, which is CV2 by CV1, which is V2 by V1. Yeah. So you have got cos omega t here, Q by Q naught here. Now what is asked for? The plates are connected when the potential difference across the conductor reduces to V2s. Yeah. So find out the current first, dq by dt, d by dt of Q naught cos omega t. Differentiating this, Q naught, what is cos omega t? Differentiated minus omega sin omega t. Substitute for everything here. You have everything. What is Q naught? Even in the beginning you said, what is Q naught is the initial charge is CV1. So substitute for Q naught as CV1, substitute for omega as 1 by root LC, and sin omega t is substituted as root of, that is power half, cos 1 minus cos square omega t. Okay. Now this C and this root C gets cancelled. Root C cancels this C and becomes root C in the top. So it is root of C by L, V1 into root of C by L into 1 minus, what is cos omega t? You have got it ready made, V2 by V1, right? The whole square power half. Simplify, you get the answer. Question number 25, it's a graphical question. See, in the beginning, what is happening? The current is increasing and the EMF should oppose, the induced EMF should oppose. There will be induced EMF since there is a current. Okay. So EMF should be negative, it should be minus. So the current increases, therefore the opposing induced EMF is negative. Remember, this should be, the graph should be like this. Then here the current is constant, no induced EMF. Current is decreasing, there should be induced EMF, but it should be positive, right? So current decreases, opposing induced EMF must be positive. Now see which can be the option. Here EMF is negative, then 0, then positive. The first one is the option. Such graph questions, graph based questions can also be asked. Here current versus time immediately should come to your mind. From this graph, what can you find? Charge. The area here should give you, because you know I is equal to dq by dt, right? dq is I dt. So if you want charge, what is it? The area of this. So first of all you find charge. Charge is half into 4 into 0.1, which is 0.2 coulomb. Once you know charge, I told you even in the beginning, list of formulae, very important formula, charge is change in flux by resistance. Here see what is given, resistance is given. You have found out charge, you can easily find out change in flux. So change in flux is Q into R, calculators 2 Weber. Question number 27, right? You have one conducting square frame, it is a square frame of side A, so its side is known, and another conductor, right? Its length is not mentioned, so you can take it as infinitely long. So it's easy for you, mu naught I by 2 pi A. From this conductor, where do you locate the center? It's given as x. This will be given along with the problem. This is a part of the question, right? From the conductor, the center is at a distance x. So mu naught I by 2 pi A. What is A here? Right? This is x, right? And this is A. So this part is A by 2, right? Okay. One is x minus A by 2. The other one is this portion, right? The other one is x plus A by 2. So EMF induced, you have conductor carrying current, producing magnetic field all over here, conductor carrying current, magnetic field will be into the paper. So in such a magnetic field, both are moving, that is this part PQ is also moving and this RS is also moving, right? PQ is also there and RS is also there in a magnetic field produced by this conductor carrying current. What is this magnetic field? At this point, what is the magnetic field? What is this distance here? Right? This is x. This is A by 2. So what is this part distance? This part distance is x minus A by 2. What about this? This is x plus this portion, which is A by 2. So this is at a distance of x minus A by 2. This is a distance of x plus A by 2. So magnetic field here is mu naught I by 2 pi into x minus A by 2. Right? Here it is mu naught I by 2 pi into x plus A by 2. So it is going to be so simple for you, right? And here it is EMF BLV, BLV, but the magnetic field here will be different from that of here. Let this be B1, that is this. L is A, side of the square, V. Similarly here, calculate for this, you get it as 1 by 2x minus A into 2x plus A to be the choice. 28, you know this already, flux. We have been defining for it, right? d phi is equal to L di by dt. Then it is L is equal to E by di by dt. So, di is equal to, you get it as voltage into time. Then it is, what is voltage? Work done into time by work done per unit charge is voltage. What is potential? Work done to move unit charge from infinity to that point. Work done to move unit charge. So, what is voltage? Work done by charge into time. So, substitute for work done, ml square t power minus 2, for time t, for charge it is at. You have learnt all these already in your 11th standard, right? Substitute for everything, you get the dimensional formula for magnetic fluxes, ml square t power minus 2 a power minus 1, right? Then this will be, the previous one will be useful for you in the dimensional chapter, first chapter of 11th standard also, right? Then the 29th question is again a graph based question. There are two lines given here in this diagram. It's so simple. Induced Emf is given, di by dt is given. You know the formula, E is equal to L di by dt. Then what is L is equal to? E by di by dt. So obviously the slope of the line should be L, right? So L is equal to E by di by dt. For which one is the slope more? Second one, the slope is more. So L2 is greater than L1. So the question is asking you to compare L1 and L2. So L2 is greater than L1 is the correct option. Then the last one. In the beginning I told you, you will be asked to find the direction of current. The first diagram, what is happening? The irregular thing is becoming a circle. So area is increasing. If the area increases, the lines of force into the paper, it is cross, right? The lines of force into the paper increases. So whenever there is an increase, it should be decrease. So how should lines of force be produced? It should be produced out of the paper. This is based on Lenz law. Here the area is increasing, right? Then the lines of force into the paper is increasing. So induced current should oppose. You should produce lines of force out of the paper. For it to produce lines of force out of the paper like this coming out, how should it be? Anti-clockwise. Only if the current is anti-clockwise, if you keep the thumb, then the lines of force will be coming out of the paper. Just imagine and see, right, it will be coming out of the paper. Here what is happening? This area is decreasing, but look at it, dots. The lines of force are coming out of the paper already. The lines of force are coming out of the paper, it is shrinking. So lines of force coming out of the paper is decreasing. This decrease should be opposed by the induced current. So the induced current produces lines of force out of the paper. Be clear, it has lines of force out of the paper. It should not decrease. So induced current produces lines of force out of the paper. Again, you should have lines of force out of the paper, then it means here also it should be anti-clockwise. So such similar questions based on the diagrams can be asked. Okay. So to conclude, I hope I have tried to cover all possible concepts for you in this part, electromagnetic induction. Please be thorough with the concepts and try to solve more and more problems. And I wish all the best for you, right, in the coming NEET exam. All the best, students.
இந்நிகழ்ச்சியை பற்றிய தங்களின் மேலான கருத்துக்களை கீழ்க்கண்ட முகவரிக்கு கடிதம் மூலமாகவோ மின்னஞ்சல் மூலமாகவோ குறுஞ்செய்தி மூலமாகவோ தெரியப்படுத்தலாம். அனுப்ப வேண்டிய முகவரி சிறப்பு அலுவலர் கல்வி தொலைக்காட்சி 8ஆம் தளம் அண்ணா நூற்றாண்டு நூலகம் காந்தி மண்டப சாலை கோட்டூர்புரம் சென்னை 6,85,000. தொலைபேசி எண் 7824015000.